So that is it for pressure issues. Next, what causes peak shape issues primarily? So as was the case with the plugged inlet frits for pressure, they can also cause issues with peak shape. And that's caused primarily, again, from the poor sample cleanup or potentially some particulate forming from the instrument. Peak shape issues can also be caused by voids in the packing as a result of either mechanical or thermal shock. And then lastly, they can be caused by chemical modifications. So if you're injecting biological samples, for instance, there can be some strongly adsorbing analytes or sample components that are causing some interesting changes in the chromatography. And column history or memory effect can also cause peak shape issues as well. Memory effect in particular has some dramatic effects with the coded phases. We'll kind of talk about that in a couple of slides from now. What we won't be talking about in this section are method development issues, so things like additives or potentially needing to optimize your additives, sample overloading, and other extra column band broadening effects that can have a dramatic effect on the peak shape as well. This is strictly related to issues with the column. So I showed this one before. This is related to partially blocked or blocked inlet frits. You can have either this peak tailing, significant peak tailing, which, by the way, can also be caused by chromatography issues as well. But like I said, we won't talk about those here today, or the kind of the shoulder as a result of blocked inlet frit. But you might also actually see fronting or kind of a front shoulder as a result of a void or a column collapse. And again, if we look at a diagram of what's happening in the column itself, it makes sense. You're going to have some kind of a void potentially that has formed at the inlet frit. You've got a portion that's coming through in kind of your main slug, so your main sharp peak here. Then you also have a portion that's going to be flying through much faster than the rest of it. So you have a small portion and then it comes out as a shoulder in the front. So how can you diagnose this issue? I won't spend too much time on the plugged inlet frits. Again, it's the same as it was for the pressure issues, QC the column, compared to the test chromatogram. For voids in the packing, unfortunately, there's not a really good test for that other than opening up the column and removing the frit. When you go and remove the frit, it's pretty apparent that you have some kind of a void that has formed near the head of the column. For chemical modifications, the best thing that you can do is try a different column or a new column if you have one available to you. This is kind of related to the column history and the memory effect. Potentially there was some kind of an analyte that went through that particular column that's causing the interesting chromatography that you're seeing, the interesting peak shape, that if you were to transition to a new column or a different column that has not seen that analyte before, if it's directly related to that, you might be able to see a restoration of the chromatography. If it is not related to that, or if it's some other issue that's going on, QCing the column again and comparing it to the test chromatogram will show you for sure, what it looks like versus when it initially was released from our site here. So typically for the inlet frits, again, it's unfortunately on the analytical columns, they can't be replaced. And I will point out too with the voids in the packing, they don't happen very often, but they will happen if you go over pressure or if you're using a high pH mobile phase. High pH mobile phases above 9, above 10 especially, will actually begin to dissolve the silica and cause that collapse in the column. So what are some things that you can do to prevent these issues from happening? The plugged inlet frit, again, you're talking about either filtering your sample, having an inline filter, or using a guard column to help collect anything that might be coming through from the pump wear or other things that might be crashing out. But there's definitely no good replacement for good sample cleanup. That is absolutely imperative. Even if the sample looks like it's clear and clean, it's always good to double check and make sure that you are protecting your investment in the analytical column. Voids in the packing, don't drop or hit the columns on a hard surface. It doesn't seem like it would be such a huge issue, but whack it on the bench top enough times and you will actually begin to disrupt or move those particles around inside. So take care of your columns. Don't drop them on the floor. Operating at reasonable pressures and flow rates. I know there are plenty of people out there who want to kind of push the bounds as an experimental science as to how quickly you can push your sample through your columns, but that's the number one way to cause a void in the packing is to push it beyond the recommended flow rate and going over pressure. And in particular, in prep columns, we've actually seen some cases where the customers have bent the inlet frits. And I'll show a picture on the next slide of what that looks like. It takes a lot of pressure to do that, but if you block your inlet frit and you continue to push it at a fast flow rate, it can happen. Ensure that you are properly equilibrating your column before you are switching your conditions. So if you're doing temperature experiments, or if you are changing your viscosity of your mobile phase, you're going from something that's very easy to push through the column, like 9010 hexane IPA, to 100% ethanol or 100% IPA, you'll want to make sure that you do a proper equilibration so that there's not a large pressure spike all of a sudden. And then one not necessarily related to the column itself or the method, but make sure there is a quick rotation of the sample injection valve. This is not as big of an issue on the newer systems, but some of the older systems in particular, it can be an issue, especially if you're trying to inject samples quickly. Just make sure that your instrument is set up properly to avoid some of these rather large pressure spikes as a result of slow rotation of this valve. So here is a picture, as I promised, of what a bent inlet frit looks like. This actually came from an SFC column, so the pressures were a little bit higher than what you might normally see on LC or HPLC, but that bent the inlet frit and pushed that inlet frit down into the column bed and caused a major void in the column. So the customer saw a decrease in the chromatography. And then other voids in the packing around the edges here, you can see obviously little holes, which again would manifest itself in either some fronting or some poor chromatography, or even potentially a complete loss in resolution altogether. And one more example, this is very, very obvious here. You can see quite a large section of this column has been ruined as a result of column packing. This again was another column that went over pressure and pushed the inlet frit down into the column bed and caused a major void in the column. And then if we're dealing with chemical modifications, make sure again, good sample cleanup. If it's something, a highly adsorbing analyte or component to the reaction, potentially looking at something like solid phase extraction to remove that might be something that you want to look into. This was the memory effect that I was talking about. It might be a good idea to dedicate columns to specific conditions. So for instance, in our lab, we have 3 different columns for ODH, so 5 micron OD. We have one for acidic conditions, one for neutral, and one for basic. That is to ensure that any modifier or any additives that have been put through the column are only acidic, no additives, or basic. In case there is some kind of memory effect, slight changes in the conformation of the polymer, you won't see odd things when it comes to your chromatography if you do this. And then also having dedicated columns to specific mobile phases is something that we do regularly here as well. If you have coded phases, in particular, if you put them in reverse phase, they have to stay reverse phase. The immobilized columns, as I have noted down here, can go back and forth between reversed phase and normal phase. There is a process for regenerating the columns. However, even with those, we recommend that you dedicate a set just for reversed phase, just a set for normal phase, because moving them back and forth too often can end up leading to shortened column life. So whatever you can do to protect your investment is a good thing. It's a little bit more upfront cost, but long term, you're probably going to save yourself in the end. Once the poor peak shape has occurred, With the plugged inlet frits, I mentioned the washing the column in the previous section in reverse, something that you can certainly try. Replacing the inlet frit if it's a prep column, or replacing the column if it is an analytical column. Void in the packing. Unfortunately, there's only one thing that you can do, and that is repack the column with new CSP. You have to clean up the column, remove any of the damaged CSP, and then replace it with the correct amount that needs to be there for a well-packed column. I'll talk a little bit more about repacking in the help section, because that's actually a service that we can help you with. And then for chemical modifications, reconditioning or repacking the column again is sometimes an option. But if it's something where, for instance, you've run a pH mobile phase that was too high and you started dissolving the silica, you will have to replace the column at that point. The reconditioning process, something that sometimes you can do yourself, the regeneration process, if it's a memory induced or a mobile phase induced kind of change in the chromatography, there are sometimes things that you can do on your own. So this is an example of an IA column running a hexane, ethanol, a normal phase, mobile phase, and 3 sample analytes over here. The sample solvent itself actually contained methyl acetate as an injection solvent, and so over time you actually see a degradation in the chromatography induced simply by the sample solvent. But if you take the column and regenerate it through a regeneration process that we have, you can actually restore the chromatography. So sometimes all is not lost. If you do see changes in your peak shape, there's a chance that you might be able to save it, and that's something that we can definitely help walk you through.